Welcome back, everyone. So now we are on lesson 8 using if-then moves in solving equations. So for lesson 8 and lesson 9, they have the same title and they have basically the same way of how we're going to do it. These are just practices on given word problems, and then we're going to convert it into equations and then solve for the following questions that is being asked. So first and foremost, we need to recall and summarize the if-then moves. What are the if-then moves? This is just a simple term, or rather, layman's term of properties of equality. All right. So properties of equality, we have addition property of equality, wherein it means whenever you're going to add on one side of the equation, you add also on the other side of the equation. And we represent as APE, that is addition. Next one is subtraction. So subtraction property of equality, we have SPE, which is mostly common, or which is commonly used. All right, we have also multiplication property of equality. So that is the one that is MPE. And of course, we have division property of equality. Wherein that is DP. Some if-then moves is also that we use, all right, our distributive property, property of addition, over multiplication. Sorry about that. All right. Or we can just, let's abbreviate this. DPAM. All right. And we also have substitution. All right. So now, write 3 plus 5 is equal to 8 in as many true equations as you can using the if-then move. So basically, it's just asking for, it's just basically asking for this 3. So if you were given 3 plus 5, all right, for addition property of equality, what do we mean by this? So 3 plus 5 is equal to 8. If we're going to add, let's say, if we're going to add 2 on this side, we need to add also 2 on the other side so that they can be equal. Same goes with SPE. If we subtract 2 on the first side, we also subtract 2 on the other side. MPE. So basically, we need to use parentheses so that you can be sure that you add them first before you multiply them to 2. And of course, DPE divided by 2 is equal to 8 divided by 2. Or I can also write this in 3 plus 5 over 2 is equal to 8 over 2. All right, so those are all true. So let's do example number 1. Julia, Keller, and Israel are volunteer firefighters. On Saturday, the volunteer fire department held its annual coin drop fundraiser at the streetlight. After 1 hour, Keller had collected $42.50 more than Julia, and Israel collected $15 less than Keller. The 3 firefighters collected $125.95 in total. How much did each person collect? Find solution using a tape diagram. So, for Julia, we can represent this as one box because we do not know how much she collected, basically. All right, so for Keller, all right, For Keller, it's going to be, it says Julia, more than Julia, so it means it's going to be adding or added, and 242.50. And then for Israel, it says $15 less than Keller, so it means we need to get Keller's, which is this, all right, minus 15. All right, so we now have the diagram. What were the operations we used to get our answers? Basically, the operations that we use are, of course, addition and subtraction. The amount of money Julia collected is J dollars. Write an expression to represent the amount of money Keller collected in dollars. So the amount of money Julia collected will be J dollars, right? And then for Keller, as said earlier, it's $42 more than Julia, so it should be J plus 42.50. We have the two expressions being asked. Using the expressions for Julia and Keller, write an expression to represent the amount of money Israel collected. As we can remember, it says there Israel collected $15 less than Keller, wherein Keller is here, J plus 42.50. So it's going to be J plus 42.50 minus 15. We can simplify it as J plus 42.50 minus 15 is 27.50. All right. Using the expressions written above, write an equation in terms of J that can be used to find the amount of each person collected. So as we can remember, the total that they collected was $125.95. So for Julia, and then we have Keller's, right? And of course, Israel, which is J plus 27.50. All right. All right. Is equal to, of course, 125.95. Solve the equation written above to determine the amount of money each person collected and describe any if-then moves used. Or wait, for this one, we can simplify it. By the way, we're going to have 3J, 42.50, because it's J plus J plus J, right? It's 3J. Then 42.50 plus 27.50 is $70. So that is now the simplified equation. So using that equation, as you can see, again, it's in standard form. So what we're going to do, because it's a positive 70, we need its opposite, which is a negative 70. And if we subtract it on this side, we also subtract it on the other side. So 3J is equal to 125.95 minus 70. So that will be 55.95. And then we divide both. Okay, so wait. We used SPE here. So 3, divide both sides by 3 and by using DP. So 55.95 divided by 3 is going to be 18.65. But this is just for Julia though, right? This is just for Julia. So for Keller, it's going to be 18.65 because that's Julia plus the 42.50, which is going to be equal to $61.15. And for Israel, of course, it's Keller, which is 61.15 minus $15 is going to be $46.15. All right. Example 2. you are designing a rectangular pet pen for a new baby puppy. You have 30 feet of fence barrier. You decide that you would like the length to be 6 and 1/3 feet longer than the width. Draw and label a diagram to represent the pet pen. Write expressions to represent the width and the length of the pet pen. So it says it's going to be a rectangular pet pen. I'm sorry if my rectangle is not perfect, but I'm going to put signs that they are equal. All right. So you are just so it says here you have 30 feet of fence barrier. So it means it's not the given 30 feet is like the sum of this, which is of course the perimeter given. All right. So you would like the length to be 6 and 1/3 feet longer. So it means we need to add, so for the length, it should be the width plus 6 and 1/3. Of course, we're going to have the width as the same as that. All right, before we proceed, all right, let us change the 6 and 1/3 into an improper fraction. So it's going to be W plus 6 times 3 is 18 plus 1 is 19 over 3. Find the dimensions of the pet pen. So for us to find the dimensions, if a perimeter is given, all right, it's going to be 2 length plus 2 width. So the given perimeter is 30 is equal to 2 times the length, which is W, plus 19 over 3, plus 2, of course, W, because that is what is given, right? As you can see here. Now, we have 30 is equal to, we use distribute. So 2 times W is 2W plus 2 times 19 over 3. Remember, we are just multiplying the number 2, the numerator. So 2 times 19 is 38. Do not forget the denominator, plus 2W. All right. Now we're going to have 30 is equal to, we can combine 2W and 2W, right? Where it's going to be 4W plus 38 over 3. Now this one, you guys are much more used to having the equal sign on the right side, so I'm going to change that because we can just always interchange them because it's an equal sign. All right. Now, we need to remove now the 38 over 3, but of course, the same process, we subtract both sides by 38 over 3. So 4W is equal to 30 minus 38 over 3. Oh, wait, we forgot to. So here, combine like terms. All right, and then here we used SPE. Now, 4W is equal to, let us change 30 into a fraction, which will be 30 times 3 is 90 over 3 minus 38 over 3. So we can write here operate or, simplify, but basically we're not simplifying yet. So 4W is equal to 90 minus 38 is going to be 52 over 3. All right, so operate. Now, we can now multiply both sides, or sorry, divide both sides by 4. So divided by 4, divided by 4. We can cancel the 4. We're going to have W. So whenever, remember of how we divide fractions, keep, change, and flip. So we keep 52 over 3. Change the division into a multiplication, and the reciprocal of 4 is 1 over 4. Can we cancel 52 and 4? No, I don't think so. So that's going to be, oh, this is DP. Don't forget. So 52 times 1 is 52 over 12, or, all right, that's going to be 4 and 1/3. All right, but that is just the width. All right, remember that is just the width. So our length is equal to the width, which is 4 1/3, plus 6 1/3. How do we add fractions? We can add the whole numbers, which is 10. And for the fractions, we just add the numerator and remain the denominator. So 1 plus 1 is 2. And then copy the denominator, which is 3. There you have it. All right. Example 3. Nancy's morning routine involves getting dressed, eating breakfast, making her bed, and driving to work. Nancy spends 1/3 of the total time in the morning getting dressed, 10 minutes eating breakfast, and 5 minutes making her bed, and the remaining time driving to work. If Nancy spent 35.5 minutes getting dressed, eating breakfast, and making her bed, how long was her drive to work? Write and solve this problem using an equation. Identify the if-then moves used when solving the equations. So just a little time, all right? Just a little time to get the given. All right. So the givens are, we got 1/3 of the total time. We can represent it as a large T or a capital letter T for getting dressed. 10 minutes for eating breakfast. And 5 minutes for making her bed. And all this three, all right, is going to be a total of 35.5 minutes. All right, so we're going to write the equation as 1/3 T plus 10 plus 5 is equal to 35.5. So 1/3 T plus, what is 10 plus 5? That is 15. All right, that is combined like terms. Next, we remove the 15 by using SPE, right? So 1/3 T is equal to, this is going to be 20 and 1/2. All right, next one. Let's change this first into an improper fraction, which will be 41/2. Remember that whenever we have a fraction, all right, as a numerical coefficient, we multiply, because that is the opposite of the division. And 1/3 or 1/3, a fraction, is dividing. So we're going to multiply to whatever the reciprocal of the numerical coefficient. In this way, it's going to be 3. So we cancel that. So T is equal to 41 times 3 is 123/2, or 61.5. Now, that is the total time though. All right, that is just the total time. What you are being asked, all right, so the total time is, getting dressed, eating her bed, oh, sorry, eating breakfast and making her bed. I'm sorry. All right. And of course, driving to work. That is the total. All right. So it means basically for us to find what will be the number of minutes she spends on driving, we need to subtract the total to the other errands that she did. So 61.5 minus 35.5. So basically, because it's subtraction, we can just cancel the fractions, which is 1/2. That will be 0. So 61 minus 35 is 26 minutes. All right. Is your answer reasonable? I would probably say yes. Why? Because the total minutes of Nancy doing her errands and driving is a total of 61.5 minutes. And with that, we subtract the errands that she did to solve for the minutes of her driving to work. All right. Example number 4. I think this is the last example. The total number of participants who went to on the 7th grade field trip to the Natural Science Museum consisted of all the 7th grade students. It said all of the 7th grade students and 7 adult chaperones. 2/3 of the total participants rode a large bus, and the rest rode a smaller bus. If 54 students rode the large bus, how many students went on the field trip? For this one, I'll show you 2 approaches. All right, the arithmetic approach, or approach means a method, you know. So basically, arithmetic is what you guys have been doing since elementary and all that, and then later on we're going to do algebraic approach. All right, so for this one, we need to divide the 54 to the 2/3. Why? This is going to get the total number of participants. So it means the participants, it means it's going to be all the 7th graders and of course the 7 adult chaperones. But you are just being asked to remember of how many students. So division again of fractions, keep, change, and flip. And then we can simplify this. This will be 27. So 27 times 3 is 81. This is the total number of participants. But you are being asked for the total number of students. So it means we need to subtract 7 from it. So 81 minus 7 is 74. All right, that is the arithmetic approach. All right. So some of you might know how to get the total by dividing. Some of you might not. So let's do the algebraic X approach, wherein this is what you guys will be doing in a much larger scale. So basically, let us represent the students as S. All right. Remember that the student plus, or the number of students plus the chaperone, all right, the total of the 2/3 of that is equal to 54. And that is how we get the equation. We just need to make sure that we understand that. If you have any questions, please do use a comment boxes below, and please do write a comment. I'll try to make sure that I can reply to your comments as soon as possible, or you can also email me. So 2/3 times S is going to be 2/3 S plus 2/3 times 7 is going to be 14 over 3 is equal to 54. Then we subtract 14 over 3 on both sides. All right. So we're going to have 2/3 S is equal to, we're going to have 54 minus 14 over 3. So we're going to have 2/3 S is equal to, let us change 54 into a fraction by multiplying it to 3. So we're going to have 162 over 3 minus 14 over 3. So 2/3 S is equal to 162 minus 14 is 148 over 3. And again, because it's a fraction, all right, we need to multiply both sides by the reciprocal of the numerical coefficients, which is 2/3, and that will be 3 over 2. So we can cancel that. S is equal to, we can cancel the 3. 148 divided by 7 is 74. So you can see it's the same. Alright. Alright, so basically that's it. If you have any questions, make sure to email me, message me on the Remind app, or you can approach me whenever you see me on the hallway in my classroom. So it's up to you guys. So I will see you on lesson 9. Lesson 9 is just a pretty fast discussion. Unlike this one, it's quite longer than expected, but we're going to keep on practicing on that, and I hope that this really helps. I hope my effort will be paid off. I hope that you guys will be really going to be devoted in this particular lesson so that we can achieve the goal of our school. Thank you so much for watching. Bye.